Montessori Grandma. Episode 34 The Periodic Table.
The Periodic Table, a lesson related to chemistry, written and presented by Geeta Vijaychandran. An introduction to chemistry. This lesson serves as an introduction to the periodic table in chemistry. The children have already done small experiments before, but are not familiar with all the elements. A periodic table is a chart used to introduce the elements that are in this world. Let us start the lesson. What are too small to be seen but make up everything, including you? The answer is atoms. Atoms make up everything. In fact, they are the building blocks for all animate and inanimate things. Plants, animals, rocks, chairs, and everything you see is made of atoms. Even the earth is made of atoms. Atoms are really small. How small are they? If you were to line up atoms edge to edge, it would take 10 million to make up a single millimeter. There are three subatomic particles we look at. The nucleus, which is the central part. The orbit is circular and moves around the nucleus. Protons, electrons, and neutrons. The atomic structure. The central part is the nucleus. The nucleus contains the protons and neutrons. The electrons revolve around the nucleus, and the path is called the shell. There can be only 2 electrons in the first shell and 8 electrons in the second shell. Protons are always positively charged. Electrons are always negatively charged. Neutrons are not charged. How many atoms are there? There are 94 natural atoms that make up everything found in nature. Scientists have created 24 more. So there are 118 atoms altogether. The atomic weight is calculated by adding up the number of protons and neutrons in an atom. So here we have 20 plus 20 gives us 40, which is the atomic weight of calcium. What are elements? Many people think atoms and elements are the same. However, atoms and elements do have a few differences when you start breaking it down. The main difference is elements are made of atoms. Elements are a group of the same kind of atoms. All the known elements on Earth can be found in the periodic table of elements. Examples of elements include gold, hydrogen, boron, carbon, neon, magnesium, silicon, aluminum, chloride, oxygen, and calcium. How many elements are there? There are 118 elements. Each element has an atomic number, which is the same number as the protons it has. The structure of each atom contains the number of electrons, neutrons, and protons it has. When were elements discovered? In 1869, Dmitry Mendeleev made a table of elements. At that time, only 63 elements were discovered, and he arranged them according to weight. He also decided to group atoms with the same properties and reactions in the same column and left blank spaces for the unknown elements. 27 years after this table was created, electrons were discovered. In 1913, Henry Moseley discovered that atoms are different from each other as they have different number of protons. This led to the creation of the atomic number for each atom. The atoms are arranged in the increasing order according to the atomic number. On the left, we have the element numbered 1, which is hydrogen, as it has only 1 proton. We have helium, which is 2, because it has 2 protons. Most substances we find on Earth are composed of compounds, which are a combination of elements. A few elements are found in pure form, like gold. The properties of elements change across a period. That is why metals are arranged on the left and non-metals are on the right in the periodic table. The table was finally completed with all 118 elements in late 2015. The periodic table of elements is an arrangement of the 118 chemical elements structured by their atomic number, electron configuration, and recurring chemical properties. Each element is special as it looks and acts differently from the other elements. They are color-coded to show groups clearly. The modern periodic table has undergone extensive changes since it was originally developed by Mendeleev and Moseley. Many new elements have been discovered, while others have been artificially synthesized. Each fits properly into a group of elements with similar properties. Elements with similar properties appear in the same vertical column or group and are numbered from 1 to 18. So each element has one more proton in its nucleus compared to the preceding one. Periods and groups. The horizontal rows are called periods. There are 7 periods in the periodic table. The vertical columns are called groups. There are 18 groups. A period is a horizontal row of the periodic table. There are 7 periods in the periodic table, with each one beginning at the far left. Period 1 has only 2 elements, hydrogen and helium, while periods 2 and 3 have 8 elements. Periods 4 and 5 have 18 elements. Periods 6 and 7 have 32 elements because the 2 bottom rows that are separate from the rest of the table belong to those periods. These 2 rows are pulled out to make the table itself fit more easily onto a single page. The atomic number of each element is written above the symbol. Groups and periods are shown here. Why are they color-coded? Colors make it easy to see trends in element properties. Color-coded periodic table displays key information about element properties at a glance. People use different colors for the chart. Here, we can look at the colors used in this chart. The last line shows the key to the colors. That is, alkaline is metal is shown in red, alkaline earth is in orange, transition metal is shown in yellow, basic metal is shown in light green, metalloid is shown in dark green, non-metal is shown in light blue, halogen is shown in blue with black shade, noble gas is shown in violet, lanthanide is shown in pink with black shade, and actinide is shown in pink. Now let us look at the element hydrogen. Each element has a name. So here we are looking at hydrogen. It has an atomic number. The atomic number of hydrogen is 1. It has a chemical symbol, which is H in the case of hydrogen. It also shows the atomic weight of the element. And for hydrogen, the atomic weight is 1.008. The chemical symbol of gold. Some elements use the first letter of the name, like oxygen uses O, but some others use other letters. This is because they have Latin names and so use the first letter of the Latin word. The Latin word for gold is aurum, so AU is used. Why do atoms form molecules? Atoms form molecules to lower energy and get stability. For example, water is a molecule that is made from 2 atoms, hydrogen and oxygen. Atoms form chemical bonds to lower energy. Atoms cannot be divided as they are the smallest units. Atoms differ from one another due to the number of protons. This is mentioned earlier. Why is the periodic table important? The periodic table is important because it is organized to provide a great deal of information about elements and how they relate to one another in one easy to use reference. The table can be used to predict the properties of elements, even those that have not yet been discovered. Does it help with experiments? The periodic table makes rich ground for educational experiments that are fun and often surprising. The elements of the periodic table include everything from the lightest gas known to man to the most dense and heavy metal, and many of them are found in everyday objects. Atom board is used in Montessori classes. The atom board is based on the Bohr model and has scalloped energy shells to symbolize the various energy levels that electrons occupy. Children can build the models of every known element on the periodic table. The atom board is sloped from the ends to the center. The center holds the protons and neutrons. The next rows hold the electrons. We have to have a set of cards with elements, and once you select an element, you can build the models of every known element on the periodic table. Use marbles, beads, or skittles for electrons, protons, and neutrons. Let us look at our body. 99.1% of our body is made up of 6 of these elements. You are 61% oxygen, 23% carbon, 10% hydrogen, 2.6% nitrogen, 1.4% calcium, 1.1% phosphorus, and other elements are 1%. Did you know atoms inside us are replaced? Yes, in 1 year, all atoms inside us will be replaced by new ones. How does this happen? We bring atoms into our bodies when we eat, drink, and inhale. We take atoms out when we sweat, exhale, and go to the toilet. Let us thank the 100 trillion atoms that are within us. Did you know that every atom that is inside your body and every atom around you was once part of a star? How can we memorize the periodic table easily? There are many songs that help memorize the periodic table. What I liked was the way a story is built to help remember them. Just a few to mention. Watch videos on the homeschoolscientist.com periodic table lesson. Watch Memorize Academy on YouTube channel. And for tricks to learn atomic masses, watch Najm Academy. These are just a few I have mentioned. There may be more which you could try out. Here are some tricks to find atomic numbers for elements 1 to 20. Write down the first 20 elements in order, numbering them in serial order. If the atomic number is even, to find the atomic mass, the trick is multiply with 2. If the atomic number is odd, multiply it with 2 and add 1. But remember there are 4 exceptions. Remember the word binaka. Remove the first 2 vowels from the word binaka and we get B and C A. So these 4 elements have different atomic numbers. Beryllium, the atomic number or atomic mass is 9. Nitrogen, the atomic mass is 14. Chlorine, the atomic mass is 35.5 and argon is 40. Remember the atomic mass of hydrogen is 1. Let us look at an easy way to find the atomic mass of elements 21 to 30. Write down the elements in serial order. If the atomic number is divisible by 7, then multiply it by 2 and add 3. An example here is the 21st element is scandium and it is divisible by 7. So multiply the 21 times 2, that is 42, and add 3. which gives you 45. Another trick, if atomic number is even, then multiply it by 2 and add 4. Example, the atomic number of titanium is 22 times 2, which is equal to 44 plus 4 gives you 48. If atomic number is odd, multiply by 2 and add 5. Example, vanadium atomic number is 23, times it by 2, which is 46, and add 5, which gives you 51. The atomic mass of zinc is 65 and cannot be found using this trick. Are there more tricks? It is for the children to discover if there are any other tricks to remember the atomic mass of the other elements. Before I conclude, here are the levels of organization from atoms to biosphere. The smallest one is atom, then comes molecules, then we have the organelles, then we have cells, then tissues, organs, organ systems, organisms, population, the community, ecosystem, biome, and the biosphere. That brings us to the end of the lesson on the periodic table. Thank you for watching. This is Geeta Vijayachandran signing off.
Montessori Grandma.